we're going to focus on changing quadratic relations from vertex form to standard form. Okay, and just as a recall, this is what vertex form looks like, where the h and the k is the vertex, and then the a is the stretch or compression on the parabola, okay? And this is what standard form looks like. So what we're doing here is we're focusing on expanding. Let's put expanding. Okay. So express each relation in standard form. So this relation right here, the first relation is in vertex form. So because this is a squared, what I'm going to do is I'm going to rewrite this as x plus 6, x plus 6. And then I'm going to use that rainbow method, okay? So x times x is x squared. X times 6 is 6x. 6 times x, again, 6x. And 6 times 6 is 36. And then we're just going to collect those like terms. So this is the same expression as the original, but one is in standard form and one is in vertex form. So this is vertex form, this is standard form. Okay, now let's try the next one. And sometimes you should try them, maybe put me on pause. Try them and then come back and see if you have it correct. So y equals x minus 7 and then squared. So as soon as you write this, see this squared, you can write this bracket next to itself. Okay, x times x is x squared, x times negative 7, negative 7x. Negative 7 times x, and then negative 7 times negative 7. Okay, collect those like terms. How we write it in expanded or standard form is y equals x squared minus 14x plus 49. And that's good. Okay, so now let's try this one. So we're going to have the same start to this one where we're going to deal with this too. So let's write everything except for that squared. We're going to expand that into x minus 7, x minus 7. And we actually just saw this, so this is perfect. So what we want to do is we want to carry that 2 all the way down, and we want to just leave it for now. Okay, so x times x, and put a big bracket here because that's actually going to matter in just 1 second. Okay, x times negative 7, negative 7 times x, and negative 7 times negative 7. Okay, we can also, again, collect those like terms, but just keep it in the bracket. Okay, so we haven't seen anything new. We haven't seen anything new. All we're doing is keeping the x minus 7 times x minus 7, that expression here in the bracket, and we have a negative 2 in front of the bracket. So here's where this question differs. All we have to do is apply this negative 2 into the bracket. And we have to apply it into every single term in the bracket. So let's go. Negative 2x squared plus 28x, and then negative 2 times 49, negative 98. And that is how we express it in standard form. All right, so let's take a look. Same thing for the y. We're going to expand that x minus 5. So keep the 3, you just bring that down. We'll rewrite x minus 5, x minus 5. And then see where that negative 8 is? Just bring that over and bring it down as well. And we're not going to touch the 3. We're not going to touch the negative 8. Now let's expand these two. The x squared minus 5x minus 5x plus 25. And then outside of the bracket, keep that negative 8. Okay, keep rewriting the 3 and rewrite the negative 8, and just ensure that you don't forget that. Okay, collect those like terms, negative 5x minus 5x. Okay, and this is, again, in the previous question where it differed. We're going to expand this 3 into the bracket, into every single term in the bracket. Do not expand it on the negative 8, because the negative 8 is not in the bracket. We get 3x squared minus 30x plus 75, and then just bring that negative 8 down. The only thing now is we're going to add those two terms. Okay, so we got 75 minus 8. I get plus 60 The curve of a suspension cable on the Golden Gate Bridge in San Francisco, California, can be modeled by this equation here, where h is the cable's height above the ground in meters, and x is the horizontal distance from one tower in meters. Okay, so if we take and make my brush size bigger, okay, if we put that into this question, what we're actually looking at here is we're looking at this parabola. See that suspension cable? Down and up. Okay, so h is the cable's height, so we'll write h here, above the ground in meters, and x is the horizontal distance. So x is horizontal distance. Horizontal distance. That's what that's going to look like. The center of the cable, so this stuff's so the last sentence here, the center of the cable is 640 meters from the tower. So again, we're marking the tower here where I just put the green. So the center, so what we're actually talking about is the vertex here. So it's 640 meters from the tower, and that would be 227 meters from the ground. Okay, so what this question wants us to do is it wants us to write a quadratic relation that models that curve, okay? And we're going to do so in vertex form. If you can see up here, this right here, let's go height equals 0.1230 That's actually the A value. And then we're going to write in vertex form. So I would do h minus, and then if we're thinking about the vertex, I'm thinking 640, comma 227. So minus 640 squared plus 227. Okay, because this A value is going to be the same as this A value here. And B wants us, so that's the equation for the height in vertex form, the height of the cable. Now, B wants us to write it in standard form. So let's do that in red. Okay, I'm going to keep 1, 2, 3, 5, 49. I'm going to keep that there, and I'm going to write x minus 640, x minus 640, and then plus 227. And again, we're going to expand these two brackets here, and we're going to leave everything else as it is. So we're going to get a trinomial and then plus 227. Okay, so x times x is x squared. X times negative 640 is negative 640x. Negative 640 times x. Okay, negative 640 times negative 640 is 409,600. And I just put that on the calculator right there. Okay, I'm going to squish it down here. Plus 409,600. Okay, so I'm going to just, I'm going to do one more line, and then I'm going to go to the next page. So 0.000549. And then we're going to have x squared minus 1280 x plus 409 600, and then plus 227. Okay, here's the next page. So what we're going to do is we're going to multiply this number into the bracket. So we have 0.000549x squared minus 702, 0.702, what else do I have? 72 x plus 224,8704, and then just bring that down, plus 227. And the only like terms here are these normal numbers. So that is going to be our expanded form. 0.70272x, and then we're going to just add this 224 and 227. So we'll keep the decimals, of course. 7, 8 times 10, 11, and then 4. Okay, and then part C. Okay, it asks, at what height does the cable attach to a tower? So if we're thinking, here we go. If we're thinking the tower and we're thinking this cable here, what I'm looking for right here is like the y-intercept. Okay, in this case, it's not the y-intercept, it's the h-intercept. So for the h-intercept, we sub 0 in for x. So the horizontal distance, x equals 0. So h equals 0.000549 times 0 squared. That obviously goes away. Minus 0.70272 times 0. And that obviously goes away. And then plus 451, 8704. So the height that it attaches to the tower is 451.8704 meters.